Hello. In this video, we're going to look at rationalizing the denominator. So the way you rationalize the denominator depends on what you have in the denominator. For this first example, we have 9 divided by the square root of 5. The square root of 5 is not a rational number, and so, but it's just one term. It's what we call a monomial. So if you have a monomial, meaning no pluses or minuses in the denominator, we're going to multiply by something that's going to make this a perfect square. Well, the easiest way to make a square root a perfect square is to multiply by what would effectively be the denominator itself. So in this case, the square root of 5, because once we square that, the square root of 5 quantity squared, it will make that square root go away. It'll simplify that square root. What we do to the bottom, we have to do the same thing to the top. And so we get 9. Remember, with fractions, you multiply straight across. So 9 times the square root of 5 in the numerator. In the denominator, you can, what's inside a square root, you can multiply by what's inside a square root. And so this would be the same thing as the square root of 5 times 5, or the square root of 25. And that simplifies to 5. Now we do see 5s in top and bottom here, but since 1's underneath the square root and 1 is not, we cannot simplifying it unless we can simplify it out of that square root. So that would be as simple as we can get it. All right, if you have a binomial in the denominator, like we see in this next example, 2 plus the square root of 7 over 6 minus the square root of 7, what we need to do is multiply by the conjugate. Conjugates are where we have the same terms, a and b, but instead of subtracting them, we add them, or vice versa. If this was a plus sign, we would want to multiply by the opposite. And so 6 minus the square root of 7, we're going to multiply by its conjugate, 6 plus the square root of 7. What we do to the bottom, we have to do to the top. Don't fall into the pitfall that those cancel out. They do not. Because of the conjugates, it still will give us a number in the denominator. It just won't have any square roots in it. All right, remember when we're multiplying with square roots, we treat it just like we would a variable. So we're going to multiply this out using any one of the methods that we would use if this was 2 plus x and 6 plus x instead of the square root. So we can, FOIL is an acronym that's used a lot if you have a binomial and a binomial, but we want to expand that. So 2 times 6 is 12, 2 times the square root of 7, square root of 7 times 6. Remember, we can only multiply outside the square root with outside the square root, and what's under a square root by what's under a square root. And then our last times our last, square root of 7 times the square root of 7 is the square root of 49. In the denominator, we're going to do the same thing. 6 times 6 is 36. 6 times the square root of 7 is positive 6 square roots of 7. Negative square root of 7 times 6 is negative square root of 7. And then our last times our last, negative square root of 7 times a positive square root of 7 is going to be a negative square root of 49. And the reason we like the conjugates is because what happened here in this denominator will always happen. If we multiply conjugates, our outsides and our inside terms will always add to 0. So if we clean this up just a little bit, we've got 12. Combine like terms, 2 square roots of 7 plus 6 square roots of 7 is 8 square roots of 7. The square root of 49 is 7. In the denominator, those middle terms add to 0. We've got 36 minus the square root of 49 is 7. And we can combine like terms there. 12 plus 7 is 19 plus 8 square roots of 7. And then in the denominator, 36 minus 7 is 29. And there are no common factors here, but if we had a common factor, we would need to make sure that we factor it out of all of the terms and not just factor part of the fraction, or we could split it up and write it as two separate fractions before we reduce it. Either one of those would be a valid answer. All right, I'll see you guys next time.